3. Graphical misrepresentations of data. So what makes a graph misleading or deceptive? There's a manipulated scale which uses a non-zero baseline which exaggerates differences. It's typically called a truncated scale sometimes, but uneven or inconsistent intervals distort proportions. I'll explain that later. Misleading categories is comparing averages to totals. Or using unclear or misleading labels. The improper use of 3D effects. 3D pie charts distort proportions and can add bias. Pictographs, reader compares area, not just height. If both height and width are scaled, visual impression is exaggerated. Omitting labels or data, missing X scales, values, or context leads to misinterpretation. Cluttering design, excessive grid lines, textures, and effects distract from the data. So, a truncated scale is setting the y-axis at a specific point. So here in 1996, the house price is $127,000. And here at this, in 1999, it's $149,000. It looks like 10 times the height. But in reality, the difference is only $25,000, which is just a 25% increase from 1996. So although it's a 25% increase, it's almost a 10 times increase or 1000% increase right here. So that's extremely misleading, and therefore you should never truncate a scale unless you want to obviously make it misleading. So for comparing averages, here's an example here. From July to August, there can be 20% of burglaries, but in other months there can be 8%. And here they use a difference. Here they add the percent of burglaries. So although it is true that 20% of burglaries happen in July to August, here they say it's 8%. Well, that's misleading for two reasons. Firstly, it should be 80% because it should be additive. All the other months should add up to what all the other burglaries are too. But additionally, they found the average here. So that means 8% burglaries happen in each month besides July and August. But that's misleading for a few reasons. In January, there could be 50% of burglaries, and that would be way higher than July and August. But they simply calculate the average, so they don't care what each individual month contributes. They just use the average formula to find that 8% of each month is where all the burglaries occur. So if they added it and put 80%, it would be more accurate. However, this provides an example or an idea that 20% of burglaries happen in July and August, and that this is an average. So here they simply use an average, and here they use the actual objective addition of 100% of burglaries. So yeah, as we mentioned here, some months can contribute like 30%, but we simply just show the average, and that's completely misleading because that means burglaries. We should be more worried about burglaries in January if there's 50%, but this makes it seem like that it's only 8% per each month, which is extremely misleading. And these are 3D pie charts. Well, firstly, 3D pie charts are misleading for a few reasons. Right here, we can actually see the height. And it looks like this is more voluminous. Although this pie chart is a little bit more accurate because they use like an actual volume. Sometimes it can make it seem like the ones closer to you have higher frequency, when in reality that's not true at all. It just looks like that. So it's just better to use a 2D pie chart, but sometimes you'll see pie charts like this. And last here is pictographs, not pictograms. And this depends on what formula they're using. If they're using like a sphere formula, 2017 is scaled twice. 2010 is scaled twice, which is why it looks like 10 times bigger. But in reality, it's only 2 million bigger, which is just a small increase in 2 million participants, but this makes it seem like it's 10 times bigger, and that's extremely misleading.